In section 5.4, we're going to study the fundamental theorem of calculus. We've already been introduced to the two major branches of calculus, that being differential calculus and integral calculus. Informally, the fundamental theorem of calculus states that differentiation and definite integration are inverse operations. Theorem 5.9, this is the FTC, the fundamental theorem of calculus. If a function is continuous on a closed interval a to b, and f is an antiderivative of little f on a to b, then the definite integral from a to b of little f of x dx can be calculated by simply finding an antiderivative for little f, evaluating it at the upper bound of integration, and subtracting the value of an antiderivative at the lower limit of integration. Let's take a look at the first example. We want to evaluate the definite integral from 1 to 2 of x squared minus 3. According to this fundamental theorem of calculus, we just need to find an antiderivative for x squared minus 3. That part we know how to do. We can use the power rule. I can add 1 to the power, divide by the new power, minus the antiderivative of 3x is going to be the antiderivative of negative 3 is going to be negative 3x. And then we're going to evaluate this. So a lot of times we'll write evaluation bars from 1 to 2, this antiderivative. It's important to remember that back when we were doing antiderivatives or indefinite integrals, we needed to have that constant integration plus c. Whenever we do a definite integral, you can choose any antiderivative of the function f you want. Typically, we choose to do the one with c equals to 0 because it gives us an easier calculation to perform. Let's now go ahead. We're going to evaluate this antiderivative at the upper limit of integration. So I'm going to stick 2 in. It's going to be 2 to the third divided by 3 minus 3 times 2. And then I'm going to subtract the antiderivative evaluated at the lower limit of integration. This will give us 8 thirds minus 6. It's going to be equal to, minus 1/3 minus 3. I'm going to distribute the negative sign through. We have 8 thirds minus 6 minus 1/3. A negative of a negative 3 will become plus 3. So this is going to be equal to 8 thirds minus 1/3 is 7 thirds. Negative 6 plus 3 is negative 3. And then if we go ahead and subtract, getting common denominators, we would have 7 thirds minus 9 thirds, which will end up giving us negative 2 thirds. So the value of this definite integral would be equal to negative 2 thirds. Let's take a look at example 2. We're asked to evaluate the definite integral from 0 to pi over 4 of secant squared dx. According to the fundamental theorem of calculus, we need to find an antiderivative for secant squared of x. Well, we know that the derivative of tangent of x is secant of x. Therefore, the antiderivative of secant squared is tangent of x. And then we're going to evaluate this at pi over 4 and 0. We substitute in the upper limit of integration into our antiderivative. That's the tangent of pi over 4 minus the tangent of 0. The tangent of pi over 4, that's going to be equal to 1. The tangent of 0 is 0. And so this definite integral would have a value equal to 1. Let's take a look at another one. We want to evaluate the definite integral from 0 to 2 of the absolute value of 2x minus 1. We've seen this before whenever we worked with absolute value, as it was pertaining to taking derivatives, but we know that absolute value is really a piecewise defined function. the absolute value of 2x minus 1, that's going to be equal to the thing inside the absolute value bars when that thing is greater than or equal to 0, or it'll be equal to the opposite of the thing on the inside when the thing on the inside is less than 0. That is, this is going to be equal to 2x minus 1, and if you solve this test condition, you would add 1 divided by 2. That's going to be when x is greater than or equal to a half. On the other hand, if I distribute that negative sign in, it's going to be negative 2x plus 1 when x is less than a half. So the expression for this absolute value function is going to change at x equals to a half. Well, if we look at the definite integral we're trying to calculate, this is the definite integral between 0 to 2, and 1/2 is certainly in there. So I've got to split this apart and do two separate definite integrals here. So using properties of the definite integral, we know that this is going to be the definite integral from 0 to a half of the absolute value of 2x minus 1 dx, plus then the integral from 1/2 to 2 of the absolute value of 2x minus 1 dx. Between 0 and a half, it's going to have the value negative 2x plus 1 dx, plus this is going to be the integral from 1/2 to 2. Between 1/2 to 2, it's positive, so it has the value 2x minus 1 dx. We can now go ahead and work out each one of these definite integrals. The antiderivative of negative 2x plus 1 using the power rule. Going to add 1 to the power, divide by the new power, plus x. This will be evaluated from 0 to a half, plus this will be add 1 to the power, divide by the new power, minus x. That'll be evaluated from 1/2 to 2. I would plug in the upper limit of integration first. I would have negative 1/2 squared plus 1/2 minus negative 0 squared plus 0. This will end up giving us a negative 1/4 plus a half. This part here is just going to be 0. Plus, let's take a look at the second one. Again, these 2's cancel. I would evaluate it at the upper limit of integration. That's going to be 2 squared minus 2. And then subtract that antiderivative evaluated at the lower limit of integration. Minus 1/2 squared minus 1/2. This is going to give us a plus 2 squared is 4 minus 2 minus, this will be 1/4 minus a half. Kind of running out of room here, but let's see what we have. So if I just come up here, we have negative 1/4 plus a half plus 0, that's 0. 4 minus 2 is 2. This would be minus 1/4, and then the minus and the minus will become a plus half. One half plus 1/2 gives us 1. 1 plus 2 is 3. Negative 1/4 and negative 1/4 would give us negative 1/2. And then 3 minus 1/2 is 2.5 or 5/2. So the value of the definite integral in example 3 is equal to 5/2.